So the moment arrived, the end of the 5th EVA. We'd done everything. We'd accomplished all of our goals, all of the instruments. We'd even put on the extra insulation on the outside of the telescope. And to my great surprise, in that moment when I gave Hubble one last little pat and a salute, I wasn't sad at all. I felt really happy that we'd accomplished all of our goals, we'd done our job and a little bit more, and we were sending Hubble off in the best shape of its entire career.
Orbiting 375 miles above Earth is a most extraordinary scientific tool that has forever changed our knowledge of the universe. The Hubble Space Telescope is one of the greatest technological achievements in human history. For 20 years, the world has marveled at its astonishing images of our dynamic solar system and the many wonders beyond. Jupiter-sized exoplanets, orbiting other suns, exploding stars and nebulas, massive exotic galaxies. These and other discoveries not only confirmed many scientific theories, including the existence of mysterious dark matter and star-devouring black holes, but also raised new questions for scientists to ponder about the origins of the universe and the endless diversity of the cosmos. Since the dawn of time, we've looked skyward and wondered, how far away are those stars? And how many are there? How did this all begin? Are there other worlds like ours out there? It was only 400 years ago, a mere blink in the cosmic timeline, that Galileo first observed rings and moons on our neighboring planets, Saturn and Jupiter. This forever dispelled the myth of Earth as the center of everything. Modern astronomy was born. As centuries passed, telescopes became larger and more powerful, able to observe far beyond the limits of our eyes. In 1924, from atop Mount Wilson, California, the astronomer Edwin Hubble first observed that the universe is made up of billions of galaxies, extending well beyond our own Milky Way. Hubble observed that distant galaxies appeared to be rapidly moving away from us. Using known stars to calculate distances between galaxies, Hubble confirmed their retreat. In 1946, the acclaimed astronomer Lyman Spitzer proposed building a large telescope to orbit the Earth. Free of the atmosphere's blurring effects, it would deliver images in brilliant new clarity.
You always need visionaries who can look out into the future and think about what's possible. And the motivation that Lyman Spitzer and others in his footsteps had was about getting above the Earth's atmosphere.
While Spitzer's idea was well received by astronomers, it would be more than 30 years before funding was granted to begin the design and development.
It took time for the technology that people had to catch up to Lyman's initial conception.
Named in honor of Edwin Hubble, the orbiting observatory's construction began in 1978 with the creation of an enormous, nearly 8-foot mirror to gather light from objects across the universe.
That's kind of the heart, the soul of a telescope. It's the thing that collects the light. Without the mirror, you don't have a telescope.
When completed, the Hubble Space Telescope would contain a wide field and planetary camera, a high-resolution spectrograph, high-speed photometer, a faint object camera and spectrograph, all capable of beaming real-time data back to Earth for analysis by scientists, and all contained within a spacecraft as large as a school bus and weighing more than 12 tons. Hubble's journey finally began on April 24, 1990, at NASA's Kennedy Space Center in Florida, aboard Space Shuttle Discovery.
Roll program.
After a shuddering, bone-jarring launch, Hubble and its precision instruments was gingerly placed into orbit.
I remember the crew talked for months leading up to the flight about what the significance of the flight was going to be. There was a lot of conversation back then among the scientific community about the Big Bang Theory, and there were those who believed that Hubble would provide all